We haven't talked a lot about graphing in statistics. Hopefully you can do some graphing, like a bar graph or a line graph, those sort of things. However, graphing is relatively important here to understand what we're talking about. In application, a lot of times when you graph the distribution out, a lot of times what you come up with is what is called a normal curve or approximately normal curve. And all that means is you have, roughly speaking, a bell-shaped curve. And so a normal distribution, the graph is a bell-shaped curve. And when I say the graph, what I mean by that is what you're graphing is the values and then their frequencies. We didn't graph those frequency distributions, but that's kind of what we're talking about here is you're graphing, along the x-axis, the axis here, you're graphing the frequency, the values along here. So whatever they are, and then their frequencies. And so what this is showing me, is the values here in the middle, if you will, are occurring most frequently. Matter of fact, the very middle is the most frequent. We'll talk more about that in just a second, but you kind of hopefully get the idea here. It's a bell-shaped curve, as opposed to something that doesn't look as much like a bell, or maybe it has two. Sometimes you might get something that has two bumps, let's call it, but or it could be skewed. You know what I'm saying? It's skewed. There's more of it over here. So this one, a bell-shaped curve, very symmetrical. In other words. It's a symmetrical graph, which means if you look right through the middle here, the left side is mirroring the right side. So like there's a mirror right there in the middle. That's what we mean by symmetrical. But one side is mirror image of the other side, okay? It's symmetrical. Okay, so that's, like we said, in application, a lot of times that's what you get. You don't get a whole lot of things that you get more of these symmetrical bell-shaped curves. All right, now we already mentioned here another facet of this is the highest point is right in the middle. One other thing we could have talked about when we were going through, we talked about the mean and median and mode. The mean, if we graph, put a distribution frequency with their frequencies, graph those, the mean is the balancing point for, the median's the middle one, but the mean would be the balancing point where we would put our finger, if we stack the bars up, whatever they come out looking like. We did, like I said, we didn't do a bar graph, but think about, when you get the mean is where, all right, so that's where you need to put your finger, if you're stacking these up like coins or something. The mean is where you put it's where it balances, okay? I say that because, all right, so I haven't told you what the mean of this is, but if it's symmetrical, where's the mean going to be? It's right in the middle, isn't it? So in a normal distribution, the mean is always that middle value, okay? Highest point. Right in the middle there. Okay, because that would be where it balances. All right, so that's significant. Now, one thing you can see here, so here's the kind of questions we're going to be talking about is, all right, so if I know it's a normal distribution, we're going to try to find out, for one thing we'll try to find out is what percentage of values may be, so let me draw another one here real quick. And they don't, they can be taller, but maybe a taller bell or a wider bell, but it has that symmetrical shape to it. All right, so this one, means here. So the kind of questions we're going to be getting to in just a second are, all right, so here's the mean, but what would, and let's just say, I'm going to make these up. Say I wanted, here's 50 and then 75 is over here. Can I figure out, well, what percentage of values are between 50 and 75? Well, what that would translate then over to in the graph would be the percentage of the curve right here, right? If I could figure out the percentage of the curve that's under, between 50 and 75 under the curve, that is the percentage of values between 50 and 75. If I were able to figure that out, right, that would be that percentage. Okay, so what I'm getting at is here, I can think of the area under the curve as a percentage of values. So that's a significant notation there. Area under the curve is going to be equal to percentage of values between certain numbers. All right, so I say that, and we'll get to some other percentages, but one important note here is what percentage of values are less than the mean? If it's symmetrical, and the mean's right there in the middle, what percentage of values are less than the mean? In other words, this. It'd be half of them, wouldn't it? 50%? 50% are less than the mean, and then 50% are more than. Right? Because it's symmetrical. You got half on this side, half on this side. With me? So those two notes are important. You got 50% above, 50% below the mean. Okay? Make sense? All right. Now, let's move on here to some others. All right. So, any questions or concerns about what we're have mentioned here? One other thing, yeah. So another thing to understand is, yeah, this I've drawn this, and it kind of just tapers off at the end, and essentially what that's saying is you could go on out forever in both directions. In actuality, what happens is it gets so close that you're basically out here and out here. There's just not going to be a whole lot of values out here. You see what we're saying? Most of the values are in the middle, right? But it does, technically speaking, you could go infinitely both ways. But as far as the number of values out here and out here, there's just not very many. Most of them are here in the middle. So that's something else we could point out. All right. So